Okay, so I wanted to go over a couple of things. Both things we're going to look at here real quick. We will be looking at in more detail later, um, but they're going to be in a bit of a rush, and maybe you'll need one of these features for your final project that you plan on making. So I wanted to at least go ahead and introduce them, and we're going to go over both of them in a little more detail later. To start with, I wanted to point out here in the delete folder where I'm going to save our Raptor file today. I already downloaded this file with a picture of a beach and just called it beach. We'll need that at some point here. So coming over to Raptor, I guess I'll start with things we've seen before, right? Well, I guess a good start, we can just do the basic example. The standard example is just hello world. Oh, yeah. Forgot to save it, so it's interrupting me. So make sure it's in the delete folder where I save that picture and give that some sort of name. So I'm just going to save a message to output for this example. We can call it message, and our standard message is going to be hello world. And obviously we could concatenate together a large message with a bunch of calculations beforehand, some user inputs, and put things together into a variable the same way, and then just output it. So output message. So we build up the message we want to output, and then we just output whatever's stored in that variable. So if I run this, print out the message here, gives a little information about the run over here in the console. But the first one is maybe we want to save our output. We don't want to just print it up and then be done with it. We want to actually save what the output is. So I'm going to clear here, and let's look at keeping stuff around. So keeping it around, well, we've talked about it before. Our symbol here is for volatile storage, the memory, the temporary one. To keep it around, we need it in long-term storage. So we need to write it to a file. So to do that, we can invoke a process that already exists. So I'll bring over a call. And the one we want is to redirect our output. So notice we can redirect our input. So that means to read from a file rather than get something from the user. We're going to talk about that in more detail later. I just wanted to go ahead and introduce this. I believe this reading and writing with files, that shows up in week 6. And then the graphics show up in week 7 officially on the schedule when we get into it. And well, for one, for the graphics, there's going to be a few things going up to go over. So I'd like to do part of that now. That way there's less to concentrate on there in week 7. But we'll get into this in more detail later. So for now, just taking what's in our program and sending it to a file. I'm just going one way for now, saving it around. And notice here in the little predictive thing down here, it gave us 2 options. We'll just use the regular one. Append means it adds it onto the end of the file, and the regular redirect output is just going to overwrite whatever's in that file. So we can either go enter a yes or a no, and then say what file name, or we can say what file to write it to. For now, let's just go with the yes. So redirect output, yes, we want to send it someplace other than the console. We want to redirect it to a file. Alternatively, we could redirect output and put the file name, and that does the same thing. And well, that's going to open a file and then write this to the file. And you've probably encountered before where you go to do something on the computer and the cursor wasn't where you thought it was. And when that happens to us, we can figure out where it was typing at it or whatever and quickly correct it. But the computer will not notice that it's in the wrong spot. If we leave this file open and then continue to do more stuff, the computer is just going to keep working in that file. So it's very important that anytime you open a file, you want to make sure and close it. And that's what the redirect output, so redirect output, and no. So redirect output with a no closes the file. So whichever way you open it, whether you just say yes and we'll go through the dialog box, or if you type in a file name to write to, make sure that you close it afterwards by saying no for a redirect output. So now when I run this program, it opens the dialog box we're probably familiar with. One thing to notice though is, well, it originates because Raptor was designed from the beginning to be a learning tool. So some functionality is stripped down. We learned the basics with Raptor, and then when we get to the full programming languages, we already have a good idea on the basics. So then we can just work in the finer details there. So it's stripped down to, some things are stripped down to just the basics, including writing to files. If we put in a file name, it will create it. But notice we don't have a button that says save. We only have a button that says open. So if we just say yes, it can't create the file. One way around that is we can just right click and go new text document, and that'll create a new text file to write this into. Test thingy. And then we'll write that output. So we'll redirect the output from the console to this text file, which basically opens it. Then we'll write the message, and then we'll close the file. So now, if we go look over at that, here in the delete folder, I didn't put any, this is where it was, so, oh, there it is. So test thingy, if we open this, we can see it printed that message to this text file instead of the console. So that keeps it around for future use. Then we could redirect input and read from that file instead of asking the user for input every time. We'll talk about that in week 6. I just wanted to point out saving stuff here at this early phase. And to practice this, that introduction program we wrote in the discussion board, there's some extra credit points if you take what you had there and just redirect the output to a file and save it to a file instead of the console. And to do that, you can either put yes here and choose the file, or type the file name in as a string. So make sure you put quote marks around a file name if you put that. So like, instead of yes, you can put testfile.txt in quotation marks. So then when we run it, just runs through real quick, and over here, you can see it created that test file and put that message in there. So either way works. The biggest thing is make sure you close the file when you're done with it. And whichever way, you just say no to the redirect output for that in Raptor. So that's how we save some stuff, and we're going to look at that in more detail in week 6, but I wanted to introduce it now because maybe you're going to want to do something and save some of your processing things before week 6. And a very similar thing with redirect input. Well, here in a second, I'll point you towards a place you can check on that, but we'll talk about that in a couple weeks. So the next thing has to do with this output. So that's saving some stuff. I'm going to delete that out of there because that's very important to keep our data around. Our term for that will be persistent data. It persists from run to run of the program. The other thing has to do with this console. So I've been using computers for a very long time, and I don't think it was the first time I saw it. I probably had some exposure to it before then, but as far as I took a moment and thought back about it, and I can say definitively that by 1991, I was using graphical user interfaces, GUIs, or we often go ahead and pronounce that GUI. So as far as I'm concerned, consoles were outdated, at least for me, 29 years ago. That was starting to seem outdated and move into graphical user interfaces, things that look a lot better than text. So let's take a look at that just to make the outputs look a little bit better, because maybe you feel the same way. It's like, I don't want to do the outputs. So in my classes, more is always accepted. So if you would rather put your output to a nice looking GUI instead of the console on your homework, that is perfectly okay with me. So we have some functions we can call to do this. So I'll kind of walk through them one at a time here. So the first one is just getting the window to write stuff into. And to do that, obviously we can just invoke a already built function, an already built process. And what we want to invoke is open graph window. So open graph window, and then it expects 2 parameters. So when we set it up, it's going to accept 2 parameters to be used in that process. And when we send them, we send arguments. So that's just a couple technical terms. So we're going to send in some number to serve, some number as an argument to fill this width parameter in this process. So open graph window, we'll make it, 500 wide and 300 tall. And that is in pixels. So 500 pixels wide, 300 pixels tall. So I'll go ahead and run this. And here you can see it opened up the little window for us to use. Already has the title bar, and then our main buttons there, the minimize and the close. So now we can put some nicer looking stuff than what we have over here. Well, our first example is not really going to look nicer. Let's just throw our message up on that GUI instead. So again, we're going to call a process, and Raptor has a fairly decent help feature built out. So if you come up here to help and general help, there's at least a short listing on most of the stuff available. So come down to graphics, things about colors, and again, Raptor was designed to be a learning software to get started into programming, so they kind of stripped it down, and so there's a finite amount of colors we have to work with. We draw things like drawing a box. We'll look at that one today, but those others are on there. Do stuff from keyboard presses or mouse clicks. Text operations, that's probably the one we want here. So we're going to use this one, display text. So here's you can just kind of look up some of the stuff, but we'll do the display text one. I just wanted to point you towards that. We also have some predictive text down here. If you kind of know what you're looking for, you can search through those, type in different letters and see what it predicts. So like display _ text, or scroll down and hit tab. And there's a few things we need to pass in. So XY, that's where are we putting the text, the XY coordinates. So just like your graphing stuff in math class, we have our X-axis going horizontally and our Y-axis going vertically. And in Raptor, the lower left corner will be our 0, 0. So X goes up this way and Y goes up this way. So let's see, we set that up to be 300 tall and 500 wide. So I'll come over, 34 over and 127 up. Just kind of picking some random numbers. The next parameter we need to fill, or argument we need to send, is what text is going to show. Well, we already have a message, so let's just throw what's stored in that variable message up there. And what color is it going to be? I'll just do it green. Then close the parentheses. That's when we need a closing parenthesis here. And hit enter. So now when we run this, we get the words thrown up there. Still looks a lot like the console output with just the words, but we could do more. So we could draw a box behind it. Again, it's a call function. We're going to call the pre-built process for drawing a box, which is going to be a draw box. So draw arc, draw bitmap, draw box. I'll select that one. And to draw a rectangle, it says x1, y1, x2, y2. So basically 2 points is what we need to define a rectangle. And if we look at this rectangle shown here in this little dialog box, if we knew the coordinates of this corner and the coordinates of this corner, then we know how wide it is and how tall it is. So we only need 2 opposing corners of a rectangle to define that one. For a circle, we just need the center point and the radius, and then that's how we define a circle. It's all the points, the distance of the radius away from the center. What color is it, and are we going to fill it in or not? So let's draw a box. I want it somewhere behind that other one, so I'll go a little bit less on the X, so maybe 65, and I'll extend it above it, 222, so 65 over, 222 pixels up, and then I'll come down to maybe 93 and 15 pixels up. I'll just draw a yellow box, and true, I do want to fill it in. And it draws like back to front, sort of. So the last thing drawn will be in front of everything else. So here we draw the box, then the text. So it puts the text will display in front of the box. So if we run that, you can see get a little, starting to get some graphics, a little yellow box and a hello world. Our message of hello world. So I want to modify that, the way that looked just a little. To start with, make the text a little bit bigger. So I'll bring in another call box, and one of our options is going to be set font size. So we can set how big it is. So set font size, and I don't know, 16 will probably work, 16 pixels tall. We'll look and see how big that is. And, well, I'll run it. So I was thinking, when I drew this, to kind of have that yellow box start over here before it and not cover quite the whole thing. So I'm going to adjust that start and end corner on the yellow box to try to be like a shadow on those words a little closer. So the words start at 34. So I'll start this at 25. Probably doesn't need to start that high. The words start at 127, so maybe 141. It's a little above it. And the words start at 127 and are 16 pixels tall, so that's going to go down to pixel 111. So if I want to stop before that, probably stop around 115 on the Y, and then the X, I don't know, I'll just pick a random thing here, 213, see what that looks like. So, sometimes it's just pick a starting point, maybe almost a random, and then once you see where it is, adjust it. Well, that'll work. Kind of covers behind the words like a shadow, but we still have all this big white space. So let's fill in that white space with the picture. So I already downloaded a picture over here in the delete folder, the same place this file is stored. And notice all these backups. Raptor really likes to back things up. So make sure you delete the backups periodically, because those add up to a lot of space. But I already downloaded this picture called Beach. It's a JPEG, so beach.jpg is the name of the file. So what I'm going to do is store that in a variable. So bring in an assignment box, and, well, Raptor will draw several kinds of images. To make it simpler, we need to convert those to just one kind to use. So we need to convert it to a bitmap. So we have this function load bitmap, and it is a drawing function. So if we, like, say, put it here before we open the graph window, said load bitmap, we'd get an error message that says, well, there's a drawing function, but there's no graph window open. So we have to do the drawing functions after we open the graph window. Part of the sequential structure thing concept. Things need to happen in a certain order for a computer. So after we open the graph window, well, then we can load in a bitmap and just store it in a variable. So I'm going to call it background, and I'm going to set it to the value of load bitmap. So that's one of the ones that'll be predicted. Load bitmap, and then just the file name for what's being loaded. Load bitmap, and our file name. File names will always be strings, so make sure you put quotes on file names. The file name is beach.jpg. And I don't need any directory because it's in the same folder. But if it's not in the same folder, you would want to put the directory path to get to it there as a string. So that's going to take that picture and store the picture into this variable for us to use later. So that loads it in, and we want it to go behind the box. So we need to put it onto the GUI before we draw the box. So right here in between them, I'm going to call this function draw bitmap. So the second one here, and we can see what parameters it expects. So it needs to know what bitmap to draw. So we have that one background. Where are we going to put it? The XY coordinates. Where's the start point for it? And it starts at the top left corner. So it'll do the top left corner, and then those last two, how wide is it and how tall is it? So I'm going to go ahead and fill up the whole space. So when we set up our graph window, we started at 0, 0 and came 500 over and 300 up. So I want to start here on the left side, so that's 0 on the X. But I want the top one, so 300 up on the Y. And then it's going to go 500, the picture will be 500 wide and 300 tall. So that'll should load a picture into the background for us. So if I run that, there we go. That looks a whole lot better than the console now. So I just wanted to show you that because, well, console output is boring. Maybe while you're putting this together, you'd like to put some better looking things in your program. So more is always accepted in my class. If you want to make the output for your homework programs look nicer and throw up some pictures and stuff, please do. It looks a lot nicer. It's good practice for programming, keeping track of order, the sequence, that stuff, because the images definitely need put together in a particular sequence. So that's there, and maybe you'll need some of these for your final project, whatever you have in mind for that. Well, I wanted to include it now instead of doing it all in week 7. And that's a couple parts we won't have to talk about in week 7 now, so we can do more when we get to looking at graphs and charts and how to do graphs and charts with our programs. But you'll definitely want to play around with it. Make sure you check that help function that has everything, or just let me know. Because I spent quite a bit of time playing around with every function available on Raptor already. So if you get stuck on something, let me know. And just like that, writing to a file, our little intro program that was in discussion board number 1, there's some extra credit if you make it look a lot nicer by throwing it in a GUI with some pictures and colors and things like that, and make it look a lot nicer. So there's some extra credit practice for that, and it's definitely one you're just going to want to sit down and kind of play around with to figure out some of the things. Let me know if you have any questions about GUIs or text files, but both of them we will be going over again more thoroughly in a later lecture. So, but still, if you start messing around with it and have any questions, let me know.